Okay, I'm going to keep going with the notes. I have switched to a different program though, because I just need more space. So yeah, maybe the notes do need more space, but you can always just supplement with extra paper, whereas I was running into that problem because I had to write on the PDF. All right, so it's page 217. And this video is kind of optional. If you think you really know what you're doing, just go for it. You don't need to watch. If you're not sure, that's why I'm making the video. So let's see what's going on. So I'm going to go through these kind of, I don't know if faster is the right way to say it, but maybe. So we want to find our origin. So origin is shifted to the, well, origin center, whatever you want to call it, to 3, 2. And then I need to find some things. So this is 4, and this is 2. So I actually know that this is the polar curve. R equals 2 plus 2 cosine of theta. So how do I know that? Well, it's a cardioid. It's predominantly on the positive x-axis. And when theta equals pi over 2, I get 2, which means that a is equal to 2. So it's going to be 2 plus 2 cosine. So I can write this equation. And I think I'll go back and fill in the PDF so that, I mean, when I finish, you might have like an answer key, I guess, so you can compare. I think that would probably be useful. Just trying to do whatever makes life easiest for everybody at this point, except for me. I would not say this is making my life as easy as it could be, but that's all right. Kind of, as I think we all know, I sort of enjoy making videos, and my face is in these videos, so that's different. First time for everything. So I would get this. All right, so I think that is the first one. And let's take a look at the next one. So I'm still on the same page. So we have this. Again, so for something like this, I have to give you the center. You're not going to be able to figure it out. You can figure out the x coordinate with no problem. But once you figure out the x coordinate, it's like, what is the y coordinate? And I don't know. There's probably something geometric that you can do to work that out. I'm just not really sure what it would be. So I give it to you. So you don't really need to worry about that. So let's see. I'm going to dot in. And then the other thing that you kind of run into is, you know, I know that I put these values at nice, oh God, missed that, at nice values. So like this is exactly halfway, and we can count on that. And then the distances are things that we can count on. So I'm expecting this to end up a negative sine limison. It doesn't have an inner loop, so I'm expecting the constant to be bigger than the coefficient. So let's see, let's find some distances. So this looks like it goes from 3 to 9. So I'm thinking that this distance right here is probably, oh yeah, great. I went too far. 3 to 9. I think that is going to be 6. Well, I mean, I know 3 to 9 is 6, but I think that I did that right. And then this distance here is going to be 2 and I think 3. And then I know that this distance is also going to be 6, I think. Right, so that's from -3 to +3. So yeah, that's 6 again. And then when I get to here, I got to go from 2 down to, from 2 down to, what are you? -7, I guess. 2 -7, 2 -7, it's 9. Okay, so I'm gonna do the thing where I plot stuff. So let me make a table. So like these videos are coming out long, but they're not perfect. So like I think you could probably keep up actually taking the notes. So hopefully you can. So we got 0 gave me 6. Pi over 2 is going to give me 3. Pi is going to give me 6 again. So I actually kind of know what I'm dealing with at this point. 3 pi over 2 is going to give me 9. What the? 3 pi over 2 is going to give me 9. Okay. So that, if I plot it, it's going to go like 3, 3, 6, 9. So we're here, and then it'll go to here, and then it'll go to, why am I starting at, what am I even doing? 6. Oh, I got you. So it's 6, and then it goes 3, 3, 6. Okay, so is this the best graph I ever made? Nope. But does it get the job done? Yes. So hopefully my face isn't like right on top of that. Okay, so this I know is going to be r equals 6 minus 3 sine of theta. And then the origin was shifted to this point right here. And that point is 3, 2. So I think I'm ready to write my equation for this thing. So it's going to be x equals 3, y equals 2. And then it's going to be plus our polar curve, which is 6 minus 3 sine theta. And then cosine theta, because that's x, and we're doing parametrics here. And then it'll be plus 6 minus 3 sine theta, because that's our polar curve. And then sine theta. Okay, I think that's pretty good. All right, let's take a look at another one. All right, this one. So people are usually, so immediately I look and I see if I had a set of axes, they would go like here. And then I don't really need the y-axis, but it would go like here. So no pedal on the x-axis means it's definitely sine. So it's sine, and then let's count our petals. So 1, 2, 3, 4, 5, 6, 7 petals. So no x-axis, it's sine. So I know that, 7 petals. So I know that it's sine of 7 theta. Then I need to know what's the radius of the circumscribed circle. So I think the best place to do that is to go from here to here, which would give me, so from 2 to negative 2 to negative 5, so 3. So I know the radius. Every once in a while I pick up these stray marks. And is that it? So our polar curve, I think, is going to be r equals 3 sine of 7 theta. And then the origin got shifted to the point, what do we got? We have -1, -2. And so I think we're ready to write our answer. So let's go with x is, y is. All right, so we got -1, -2. And then it's going to be plus the quantity, 3 sine of 7 theta, and then cosine theta, because that's always there. And then plus the quantity, 3 sine, of 7 theta, and then sine theta, because that's always there. Okay, I think that's our equation. If you graph that, you'll get what you're looking for. All right, let's do one more here. Okay, I see petals on the x-axis, definitely cosine. So it's going to be cosine, so x-axis therefore cosine. So I'm going a little quicker on these because, as I mentioned, if you know what you're doing, you're probably not watching this video. If you don't know what you're doing, slow it down, watch it again, watch it as many times as you want. All right, how many petals? 1, 2, 3, 4, 5, 6, 7, 8 petals. So 8 petals. So I'm gonna know that n is 4 because we double the even numbers. So if we know the petals and it's even, we cut that in half. So I get n is equal to 4. I need a radius. So it looks like the radius is just gonna be 4 because of this distance for the circumscribed circle. So I think we're dealing with r equals 4 cosine of 4 theta. It's a lot of 4s on that one. And oh, there's even more 4s because the origin has been shifted. So our shift is to the ordered pair -4, 4. So this is just going to be a ton of 4s when we write it. So let's do that. All right, so we get x and y and stray mark. So this app that I'm using is called Doceri. Seems to get a lot more stray marks, and that's kind of interesting because I don't know what's causing it. So every once in a while you get like little app reviews, or in one of the videos I said I really like the Apple Pencil, still like it a lot. Still think it's probably worth 10 times what my other stylus was worth, and I regret not purchasing it years ago, but what are you gonna do? Plus, all right, so 4 cosine 4 theta, and then because this is x, we pick up another cosine theta. And then this will be plus 4 cosine 4 theta. And it's going to pick up a sine theta because it's the y value, sine theta. And there you go. I'm going to stop this here. I guess I'll come back and I will do more of them. And I hope you are finding this helpful.